Oh, I like this question. So H0 is lambda equals 0.8, and H1 is lambda is greater than 0.8. But we're going to do 10 rolls, aren't we? So X is a Poisson with a mean of 8. Now let's read through this. In the summary, if 12 or more defects are there, so if it's 12 or more, then we will reject H0. Okay. If there are 9 or fewer, then we will accept H0. But if we're in the middle, so if we're in 10 or 11, then we'll do something else. Then we'll do another sample, and we'll then do X is 8 or more. So you get a second chance then, basically, but it will be rejected if it's 8 or more. Okay. Right, so what about this rejection then? So we've got a couple of things to think about the rejection, haven't we? It's rejected if X is greater than or equal to 12. So we want that. But also the probability that X is 10 or 11 and then greater than or equal to 8. I think that's my concept there for all of this, isn't it? Feels about right. Let's get the calculator and see what we can do. So I've put my Poisson calculator here, and I've just started with the first one where we reject it straight away. So that's the mean is 8. We're going for more than 12 or more, and so that is 0.1119. So that's just they're just rejected straight out. Now the other ones are, so well, let's do the 8 version here. So on the second bit, that is 5470. And before we have that, what about the between? So 10 or 11. So that is 0.1714. Does that make sense? So either you're going to reject it straight away, or you get a second chance, but you still might rejected it there. Okay, what do we think that is? 0.1119 plus 0.1714 times by 0.5470 gives the probability of a type 1 error here is 0.2057, and that is the size of the test. Now there's not a lot more thinking to do for the power. In that for the power, it means we are going to reject, so exactly the same thing again. So it is the probability that X is greater than or equal to 12, and the probability that 10 is less than or equal. So it's exactly the same thing again, but this time we're now given that lambda equals, well, it says lambda equals 1 here. So in my Poisson here, we're going to go for lambda equals 10. Because obviously it's 1 per go there. So exactly the same maths as we did before. The distribution, the Poisson, but this time I'm going to have a 10 here. So that makes that bit there 0.2388. The more than, so more than simply 8, yeah, more than 8 is 0.7797, and more than 12 for the automatic rejection, more than 12 is giving me 0.3032. So when I put all of that together, I get 0.4895 or 4894 or thereabouts.